Okay, straight lines.
Yes.
Okay. Okay, so I mean, I have repeated this many times, like everything what we are working on, we need to give a more in-depth understanding about what is the meaning and how we are getting things with that. Okay, so like I mean the topic straight line itself, it is not straight away coming as a straight line. So we started using the numbers, and then let's say even if you say that something like x equal to 7 or 3, for example. Okay,
Yeah.
so I mean, we know that there is a variable in the name of x, and it is going to have a fixed value 3 because of the substitution. And there is a other way to represent this. Like we can use a number line for the name for the x, and I mean probably it could have both positive and negative values. So it could be, it can take all possible values, real values. Okay, on this axis. And particularly, I mean, when we put the reference 0, we call this as the reference, and we say the first, the gap, okay, the gap amount, when you fix it as this is the 1 unit quantity. So we can fix whatever the value we want. So if you fix it as a 1 amount, then this become a positive 1, and this become a positive 2 and a positive 3, right? So this is the particular point we are talking about. This point is our x equal to 3. Is it okay?
Yes.
So we have the other direction also, the negative direction. So with respect to the reference 0, we have the positive side, and then positive direction, and then there is a negative direction, right? Negative direction. So all these things, we simply say that it is a number line, and we learned very long time ago. So also the number line, we can even say it is a real number line, okay? Because the values are not complex. Is it okay?
Yes.
So now this x we call that as a independent variable. Independent variable. So this independent variable, what it means, like there could be a real quantity, like a time or a space or something like that. That is the kind of variable we are talking about. So definitely there will be some kind of units attached with that. So we need to keep an eye on that. For example, it could be a time. Then in that case, it will be a seconds, right?
Yeah.
And it could be our space or length. Then we say that as a in terms of,
Meter.
right, like that it can. So these variables, like as time progresses or if we move, these will change. They are not dependent on anything. So these are all the starting point, and dynamically they can change. And now there could be some other variable which can dependent on that. So normally we write that variable name as a y. We call that as a dependent variable. Okay, dependent variable. So now obviously the y is called a function of x. So y is a function of x.
Yes.
Function of x. So in the case, like when some value, if the x takes some value, then we are interested in knowing how the y will vary on the x, how it is dependent on. So that is the main important interest we have. Depending on the situation, we need to do some measurement and everything, or observation or something. Then we may know for the x and y. For example, I make an experiment. So with the x, and I'm also measuring the y. Is it okay? So let's say
Yes.
I have a 0, and the y comes to a 0, for example. And then I, okay, 0 is better. I use it as some value as a 2 to begin with. Okay. And then when I go for a value 1, I measured or observe or whatever it is we did, and it comes to a 5. And when this goes to 2, and this goes to 8, for example. And then when it is a 3, then it goes to 11. Okay. And then 4, it goes to our 14, for example. Okay. So what we
Yes.
observe, the x is changing, right? X is changing. So I'm going to make the difference between any consecutive values, that is going to, I call that as a dx, for example. Is it okay? So the,
Yes, sir.
the previous value is here. So the gap, I have chosen very easy way, that the difference between 1 minus 0 is here. 1. Yeah, I keep it like the uniform kind of gap. Okay, this is better. Have a uniform gap is better, right?
Yes.
So now the y is changing. Definitely the y value is also changing. So we are interested, first of all, find the dy also. So what is the change happened in the y? That will be like there is a 3, and there is a 3 here, and there is a 3 here, and there is a 3 here also. Right? So now, as the y is dependent on the x, we want to look into what is the relative change between the two. The dependent variable changed because of the change happened with the independent variable. So now we are finding the ratio between the two. Is it okay?
Yes.
Okay. So the ratio is, okay, I mean, as we did it all 1, dx value is all 1. This is also going to be 3 over 1 is going to be 3. 3 over 1 going to be 3. 3 over going to be 3, like this. Is it okay? 3 over
Yes.
going to be 3. So in the example case, I can say that this could be our, for example, this could be seconds, and this could be our, for example, a displacement in meters. Then still this quantity is also in second, and this quantity is also in seconds, and this will go to a units of meter per second. Is it okay?
Yes.
So we are saying that the dy by dx is going to be a constant in this case, right?
Yeah.
Constant. So now we need to make that as another parameter. So let's call that parameter as let's call it is a constant parameter. We call that as a parameter, because in this particular observation they are all 3, but if you do another experiment, it could be 5. Yeah, so it is not changing when the x or y is changing, but it can change from case to case. Do you get that? Experiment to experiment. That is why it is so we can still use the dy by dx as our parameter and m, but don't think that it is not a variable. Okay, not variable. Okay, it can change from case to case, but for a given case it is a constant. That is why it is called a constant parameter. Okay,
Yes.
constant parameter. So that is going to play a role in deciding what is the, so we are interested in finding what is y of x, right? What is this looks like. So now we find one parameter is playing a role, that is the change happened in the y with respect to the change happened with the x, that we call that as a m. And we stop here. We don't go for further investigation or analysis, because that become a constant. That is where we stop, right?
Yes.
So now if I take this as the starting point, so now I know that there is no further change happening. So I take this particular information dy by dx as my m, that leads to dy equals m dx, right?
Yes.
And now we know the small change happened in the y. So what is that meaning? So if you have a x, the x is vertical, horizontal one, right? So we are making small pieces of this, and each one of them we made it as a dx. And in the y also we split that into small equal pieces. Each of them are dy, right? So this is y. So if you add all of them, that is what integration is, we will get back our y. So if you add all the small x's, then you'll get back x. So that's the reason we do the integration of dy equals the integration of m dx, right?
Yes.
But now we have done an experiment. We have an observation and everything. So we are interested from x equal to 0 limit to for all the values of x, any general value of x. Is it okay?
Yes.
At the same time, the y has become, y is when the x equal to 0, in our observation, the y is actually 2. Is it okay?
Yes.
From 2 to all the values of y. We are interested in any general value of the y. Is it okay?
Yes.
So now the y becomes, the integration is completed. When you complete, it will become a y, and it has a limit from 2 to y equals, in this, m is a constant, right? So
Yes.
m can be taken outside the integral. So that will be m, and x got integrated. Dx integration is a x, and the limit is 0 to x. Is it all okay?
Yes.
So now when you substitute the limit, it will look like y minus 2 is actually equal to mx, and our okay, this is also the m value is actually 3 in our case. So y can be written as 3x plus 2. Is it okay?
Yes.
Okay. So any questions so far?
No.
You see everything comes in a
Yes.
systematic way, right? So
Yes.
let me go to the new page. Can you go to the new page, please?
Yes.
Yeah.
Yes.
Okay. So we just got the particular equation like y, which is a function of x. As the x changed, y also changed. And that is why we say that, and what fashion it is changing, it is something like mx plus c. And in that particular case, in the example of the problem, we got it like our m value is a 2, I mean 3, and our c value as a 2. Okay. So y equal to 3x plus 2. So this one, now as I said, we have data. Now x needs its own number line and y needs its own number line. So rather we will be using our 2 number lines now, right? One for the x and one for the y. Okay. So the y. So now if you plot it, this will be, I mean, the tabular column is already there. So it will be passing through the 2, and it would be with a slope of 3. So something like a straight line like this. Is it okay?
Yes.
Okay. So this is a straight line. This whole thing is a straight line. As the first order difference itself, the relative first order difference, that is dy by dx, becoming a constant, right? Constant. Yes. In this case, it is a m, and we call that as a gradient or slope, right?
Yes.
And the other one is, another parameter is also playing role, that c, we call that as a y-intercept, right? Intercept. So this point is going to be the 0, our 2 in this case. And then if you take a 2 points, it could be any 2 points. Okay. So we are seeing that this point could be our x1 and this point could be our x2. When you take 2 independent values for the x, so corresponding points may look like this point can be x1, y1, and this point could be our x2, y2.
Yes.
That means the y value, corresponding y value is a y1, and the corresponding y value is a y2. So now we are interested how much slope this is. We already know that m is a 3, but in the graphical representation, this is simply when we close this gap, this will be our dx. Do you get that?
Yes.
So here x is equal to x1 and it is going to a new value, which is this x is actually the previous x added with the new value. Do you get that?
Yes.
Okay. So this difference will be our x2 minus x1. Similarly, this is going to be our dy. Same understanding. This is going to be our sorry. Yeah, this should be minus x1. Sorry about that. Is it okay?
Yes.
So the extra bit that has changed. So this is going to be y2 minus y1. Is it okay? So as it is
Yes.
a straight line, you can choose the 2 points as big as possible, gap between them, or as small as possible. It doesn't matter because it is a straight line. So the change
Yes.
happened will be uniform because the dy by dx is going to be a constant. So that makes our dy by dx is going to be, which is defined as our m, is going to be our y2 minus y1 divided by x2 minus x1. That's it. Okay.
Yes.
So all of them are making sense for you.
Yes.
So we started with independent variable number line and slowly moved on to all the way here to see a straight line and a bit of a calculus involved, both the integration and differentiation also. So if you take this particular thing, we say that y equal to mx plus c, then straight away the differential calculus, we know that y is a function of x. So if you do the dy by dx is going to be d by dx of our mx plus c, right?
Yes.
So now it is from the x point of view, it is an addition of two quantities. So now distribute this is mx plus d by dx of the c. This is okay. So now when we look from the x point of view, this is m times x, meaning there are repeatedly so many number of x's added. And how many of them? There are m of them. So, we could take the m as a constant as it is not dependent on the x. Then m is outside, that will be dx by dx plus x is saying I am changed from x to x plus dx. It is asking this quantity c, are you changing or not? C is going to reply, no, I am not changing. So the change happened is 0. Is it okay?
0. Yes.
Okay, so the dx and the dx can be cancelled, factorized to 1 to 1, and this is going to be m. So for a straight line, the first derivative straight away a constant, right? That is why it is,
Yes,
it is a straight line and it is not a function of the x or the y. So that makes the whole understanding and conclusion about how to go about a straight line. So in the graphical representation, I need to give a bit of an idea about, as we used the number line for the x, there is a number line for the y. So they are very simple. So when we take any point, when it was only 1 point, in the case we had x equal to 3. Remember that, the previous page?
Yes, sir.
Right. So here, it is not one number line. There are two number lines. So when the x equal to 3, in the only one number line case, that is a one-dimensional case, it was a point. But in here, this will be a straight line. Do you get that?
Yes.
Anywhere, if you go vertically above and below and on the x equal to 3 value, x will be always 3, but y can be anything. Vertically, the y will take any value, right?
Yes.
So this particular equation is called x equal to 3 equation, and the y can be anything. Similarly, if you fix a particular value for the y, then it will pass the y-axis for a particular value, whatever the value we choose. In this example, for example, it is a -3, for example, that is y equals -3. So in this case, this particular straight line can take only y value as a -3. That is why y equal to -3 is the equation for this straight line. But x equal to 3 and y equal to -3, they intersect. Do you get that?
Yes.
So here both the x value and so on a point on a plane, both the values for the x and y will be fixed. It is not a line, it is a point. And we first write the value for the x, comma, the value for the y, we write it. So we call that as the coordinate points. Okay. Coordinate points. So the coordinate points and the axis and the whole plane, this is generically a graphical way of representing whatever we need. Either if it is a one-dimensional data like x value or a y value, we know how it can be plotted here and what it is represent. It is only going to be a one fixed value for a x. It will be a vertical line passing through the x-axis at that value. Is it clear? Like a 3.
Yes.
And if it is going to be only a fixed value for the y and x can be anything, then it is going to be a horizontal line passing through the y-axis for that particular value. In this case, y equal to -3. So if you have both the x value and the y value fixed, then we are talking about the particular point where the two lines intersect. That's why both the values are fixed. Okay. So this graphical understanding and the representation, and also most of the time origin is a point 0, 0, right? So we say that this axis is also linear. Linear in the sense the gap between any two consecutive points is fixed. Do you get that? 0 to 1, 1 to 2, 2 to 3. Like that. The y is also linear. I mean linear. That is called a linear scale. The y is also a linear scale. Linear scale. Because it is a property what we have chosen. But need not to be. Like there can be non-linear scale also. Maybe you might have already seen that. Yeah, log scale or whatever. Log scale is one example. But it could be non-linear. Even it can be quadratic. Do you see what I'm saying?
Yes.
We are always allowed to take a number line as we wish. It could be x squared, right? You can be x, but it may look like, okay, let's say this is representing a, how to say, so let's say this is our 0, 0, and this value could be a 1, and this value can be a 4, and this value can be 9. Nobody stops us. Do you get that?
Yeah. Yes.
So this goes, the gap is not uniform. So now the gap is, this is a 1 gap, and this is a 3 gap, and this is a 5 gap, right?
Yes.
And you go one more further, the gap between the 1 and 3 is a 2, and 3 and this is where it stops. Do you get that?
Yeah.
So this is the first difference, and this is the second difference. Do you get that? Second difference is the constant. That is where we call that this is a quadratic scale. This is a quadratic scale.
Yes.
Quadratic scale. So nonlinear means it is not only log. Log is in the scale of logarithmic value in terms of e power x. Do you get that?
Yes.
But here it is simply x squared. That's it. Do you see that?
Yes.
Okay. So you are okay with all about the straight line?
Yes.
Okay. So when the problem comes, okay, whenever there is a problem, I go to the next page. Can you move to the next page?
Yes.
You are in the next page.
Yes.
Yeah. Okay. So when the problem is given to us, then we need to, okay, don't superimpose or force yourself like, okay, I'm going to do this because it is a straight line problem or anything. A problem could be a straight line or it cannot be straight line depending on what is given to us. Do you catch that?
Okay. Yes.
Okay. Can you take any problem in your thing which you find it difficult or something like that? Take that.
Once.
Yeah.
Okay. So
Send it in the WhatsApp or
yes.
yeah.
1 minute.
Yeah.
Oh, yes, you have sent it out.
Yeah. So each problem, like every line, every word, we need to read it and analyze, and that should become our habit. Okay.
Yes.
So, and also when we keep doing like that, maybe in the beginning it may look like it is taking bit of a time, but we will make ourselves quite as such a critical person about everything, and very soon you will find that it won't taking time, but naturally we will be doing that.
Yes.
You see that? So that is what makes us a thorough person in understanding or listening or reading or going through for our own work or anything else or everything else. And that will make us immediately, the process will be, I mean, it will be a cyclic one in the brain. It will work like that. Like we when we look at it, it will trigger the right things that is needed to how to proceed with that, how to do that, what to be done, and everything. You get that?
Yes.
So keep that as a handy thing. Okay, let me leave that. Yeah, it is. Yeah, it is a straight line, right?
Yes.
Straight line, straight. Because I'm just giving the name for the file I'm downloading. Okay. Okay, let me open that. So here it says find the image of the point 3, 8 with respect to the line x plus 3y equal to 7, assuming
Assuming the line to be a plane mirror.
a plane mirror. Okay, so that's it. Find the image of point. Okay, image, let it be, because image is connected to the mirror, that is connecting to the end of the line. But a point immediately will give us an idea. Both the x, it is only on a two-dimensional plane. Do you get that? It is not on a number.
Yes.
It is not on a single number line. It is on a
Yeah. Yes.
so it needs two axes. So normally we call that x and y, and the values are fixed like a 3 and 8. And when the two lines x equal to 3 and y equal to 8, they intersect, that is where our point is going to be. And with
Yes.
respect to the line, so now we have a line. So when we used the axis name as a x and y, that is the variable name for the straight line that is going to vary. So that is representing a line. This is representing a point on the same graph, right?
Yes.
Okay, so that is what, like, so let me write it. So the point name is 3, 8, right? I even use a name for that as a point. And then the straight line equation is what? What is
X
it?
plus 3y is equal to 7.
X plus 3y equal to 7. So here we have a job to do, because when we choose, this is going to be our x and this is going to be our y, then that is the horizontal and the vertical. That is what the standard people use. Do you get that?
Yes.
So this axis is actually, we are going to use it for the y, and the one horizontal is going to be our x, right?
Yes.
And obviously the point, let's say this is going to be a 1, 2, 3, and then there is a 8. 1, 2, 3, 4, 5, 6, 7, 8. You get that? So this is going to be
Yes.
our y equal to 8 line, and this is going to be our x equal to 3 line, right? So our point P is here. So even I will extend and use that as this is y equal to 8 line and this is x equal to 3 line and the point is 3, 8.
3, 8.
Okay. So now on the same two-dimensional graph, we have a straight line. They are saying that that is a mirror. Let it be. So here, first of all, we need to write it in a suitable way so that that will look like a y equal to mx plus c. So this is going to be written as y is going to be equal to minus 1 over 3 times x minus plus 7 over 3, right?
Yes.
Okay. So in this, we have our m is actually equal to minus 1 over 3 when we compare it with y equal to mx plus c, and our c value is a 7 over 3. So 7 over 3 is going to be approximately 2.666, right?
Yes.
Okay, say 2.67. So 2.67 is going to be somewhere here. Is it okay?
Yes. Yeah.
Okay. And the m equal to 1/3, -1 is a negative slope and 1/3. So it is -1 is okay. 1/3 is less than 1. Do you see that?
Yes. Yes.
So 1 is 1, m equal to, okay, this is generic one. M equal to 1 is actually a 45-degree line. Do you get that? 45-degree straight line. STARG, straight line. So why it is so? We are saying that dy by dx is equal to 1, right?
Yes.
This leads to dy equal to dx. And if you integrate both sides, this will lead to simply y is equal to x plus c. So the intercept can change, but whatever the value of the x, it will be exactly the x value will be the y value. Do you get that?
Yes.
If the c is 0, then it passes through the origin. Then depending on the c positive, then the line will be shifted up or shifted down if it is negative. But in the case of our problem, it is a negative 1/3. 1/3 is less than 1. Then that means it is shallow. Do you get that? 1 is 45-degree line. So the angle is less than that, but it is negative and it is passing through that. So 1/3 line is going to be a shallow line, and it is going to be like okay, let me draw a 45-degree line, okay, to just to give an idea, right?
Yes.
Okay, we can plot few points, but I'm just saying, even without, let's say this is our 45-degree line. Okay, so this has to be shallow than that. Do you see that? 1/3. You get that?
Yes.
Okay, so this is, but better to plot the points. Do you get that?
Okay.
Plotting the points is not easy, but you know how to do that, right? Small tabular column.
Yes, sir.
Yeah. So now this is our line, right? This is a mirror. Okay. Okay. So what this mirror will do? Think about it. What the mirror can do? Hello? Hello, Karishma, can you hear me?
Well, I can't hear you.
Yeah. Hello. Can you hear me?
Hello?
Yeah, can you hear me?
Yes, sir. Move to the page.
Yeah.
So what was your question?
Yeah, I mean, what the mirror will do? It will just...
it will reflect it it will reflect it with respect to that line.
Yeah, that
in
line
the opposite side.
Yeah, it will go to the opposite side, right?
Yes.
So, I mean, okay, I mean, there may be a lot of ways to do that. One way, I mean, we already covered and I discussed about that. You remember the multiplication with the -1.
Yes, sir.
Okay, what this will do, let's say if you have a number on the number line axis, let's say it is our +3, then you take the 3 and multiply with -1, it will rotate it 180 degree here, right?
Yes, sir.
Go to -3. So that will rotate by 180 degree. And this is happening because this works as a mirror.
Yes.
Okay, so if you multiply the -1 for a number, then this particular vertical line that is going to act as our mirror. Do you get that?
Yeah. Yes.
But now, I mean, this vertical line is actually y is equal to, I mean, x is equal to 0, isn't it?
Yeah. Yes.
So for x is equal to 0 line, this is fine. Also, if you have a number on the vertical axis here, for example, our 3 is here now, and also the rotation should be on the anti-clockwise direction. So you take this number and multiply with -1, then this will rotate 180 degree and it will get reflected here.
Yes.
Okay, so that is on the y equal to 0 line, it will reflect. So 3 times -1 will give us a -3. Okay.
Yes.
Now think about, just to extend the thought process. Let's say we have a not this vertical line and also not a horizontal line. Let's say take it as a 45 degree, just for a simple example. You get that?
Okay. Yes.
Just to get it as a idea. Okay, still the origin, it passes through the origin. That is a strict condition. That is the example we are taking. So this is y equal to x line, right?
Yes.
So if you have a point, let's say there is a point here. Take the point as it's not that good point, but take it as a 3,4, right? No.
It will be y
no.
is equal to x.
Yeah, no, not the 3, I don't want to take the point on the line. On the line is not the, I drawn the line for my mirror. Do you get that?
Yeah, it is 45 degrees.
Yeah, it is. This line is also, yeah, okay. Take a point which is somewhere here, right? Okay. Our point here is, for example, -2, 3. Is it okay?
Yes.
Okay. So let's say if this is getting reflected by this y equal to x, what will happen?
It will get reflected to the fourth quadrant, so it will be 2, minus.
Yeah, okay. So there is a good idea what is going on. So it will go here, right?
Yes.
So it will become 2, -3, isn't it?
Yes.
Okay. So that is actually what it has done. This is x equal to y. So both the x and y got multiplied with -1. Do you see that?
Yes.
This also got multiplied with -1 and this also got multiplied with -1, right?
Yes.
Okay. Now just to extend the idea. Now this is not the line. Now I'm going to use the same x equal to y, I mean y equal to x, but I'm going to now give a bit of a shift. Okay, that is the first thing I will go for. Okay, what I'm saying, still 45 degree line, but this time it is passing through our, this is y equal to x plus 1. Okay, so now take the same point here. This is going to be our -2, 3. Then when you get shifted, I mean reflected, what will happen?
It won't be the same. It will be a little bit above -2. Sorry, it will be a little bit
So
above 2.
First deal with the -2. What will happen to the -2? So -2 is our point here, right?
Yes.
for example, right? And this is our 3. So the line is shifted 1 above, only the x value, y value got shifted up. Do you get that?
Yes.
So that means what? The -2
A
change
-2 will become 2.
2. That will stay as a 2. But
Okay.
3 will get, instead of -3, it will go only -2. Do you get that?
Okay. Yes.
Does it make sense?
Yes.
So this point is going to be -2, plus 2,
2,
yeah, 2, -2.
yes.
So here, what has happened? This m value is a 1 and the c value is also 1. What has happened? The m value is used as our -1. Do you get that? So this point, let me call this point as a comma b, for example. Make it general point, right? So what has happened to the a comma b? The a got multiplied with minus m. Let's take it like that. Is it okay?
Yes.
Okay. And the y got added with, subtracted with 1, right? No, it got.
Uncle, how will it be minus, say?
Excuse me?
Uncle, won't it be A only? Because
No, the a is a -2, right? That should become a +2, right?
oh, okay. Yes. Okay.
The value remains the same. That I'm using
Okay.
the value. Magnitude remains the same, but it will be rotated by 180 degree in the x.
Yes.
Do you see that?
Yeah. Okay.
Then the y value still, it is going to be, if I am not wrong, it is going to be our -1 m multiplied by b and subtracted with our c. Is it okay?
Yes.
Okay. So what I'm saying, b is our 3. So I'm using that. So the value will be -1 multiplied with the 3. And we are going to have, it will be added with 1, right? Add plus c, isn't it?
Yes.
Okay. So it will be +1. That will be -3 plus 1 will be our -2. Is it right?
Yes.
Okay. So all we are getting here is something like let's see whether that is meaningful. So AB will be reflected to a coordinate points according to the straight line. The -m multiplied with our a, comma, the -m multiplied with the b plus the c value. Is it okay?
Yes.
Okay. So let's see that. Okay. Whether this is meaningful. Let's say now I am going to let's leave the c. I'm going to use a line now just for understanding. Now I am going to use a off, m equal to off. So let's say our mirror is going to be y equal to off x. Is it okay? So time being, I just leave the c value 0. Is it okay?
Yes.
Okay. So now this will be a shallow. So this will be like something like this, isn't it?
Yes.
Right. Okay. Of the x. Okay. So now take the same point. So our point is remaining the same. So here we are going to have -2, 3. And now because of this reflection, what will happen? So this will get reflected. So this will get reflected on the, it will pass through the origin. And it will go somewhere here. Right? Isn't it?
Yes.
Okay. So now look at here. So what we are saying here is this will be only the slope will act. That will be our the -2 multiplied with the minus of, this will be +1. Right? Reflection will be a +1. and a comma, and y value will actually, the y will be increasing. Do you get that? Or y value remain the same?
It will be by 2.
Y value become only negative. No, it will change, isn't it?
Yes, sir.
Yeah, it will change. It will change. It will change definitely. Okay, let's go for a better. I go to the next page.
Okay.
Okay. Okay. So what I'm
Yes.
going to do, this is much better. I will do that just for understanding, because there is a rotation going on and we could use this, right? So our line is, the mirror is like this, right? Mirror is like this. What the mirror says, y equal to mx, right? Time being, let's keep it as a mx. Okay, we can substitute whatever the m value we want. So what that m is going to be, that is going to be this value. For example, this delta y dy, this is our dx, right?
Yes.
Okay, so now this is going to be our because when the mirror is changing the slope with this as the pivot, this is going to rotate. Do you get that?
Yes, sir.
Okay, so we are going to say that, let's say if you take a point here, it could be our -2, 3, for example. Then we are talking about take the distance from the origin, draw a circle. You see that?
Yes.
Okay, so now this will go to the other point. Do you get that?
Yes.
With the diameter, it will go. So the 0, 0 is the center, and this is going to be, this is also going to be our radius of the circle. This is also equidistance. Do you get that?
Yes, sir.
So let's say the unknown value is, call it as a p, q, for example. Then the 0, 0 is going to be the midpoint between the -2, 3 and p, q. Are you with me?
Yes.
Okay, so how to find the midpoint of a straight line if you know the coordinate points?
X1 plus X2 by 2.
So this is saying P minus 2 over 2 is 0. Also, the Q plus 3 over 2 is also 0. Do you guess that?
Yes.
So this goes to P is actually equal to 2 itself, right?
Yes.
And our Q is going to be minus 2 over 3. No, but what we did not. Yeah, this is okay, right?
Yes, sir.
This is okay. This is okay, fine. So now what we are going to do, let's say we are going to shift the, let's say we are going to shift the, let's take the circle, but this time around, I'm going to shift the axis. Do you get that? Origin is here.
Yes.
Okay. This means what? We are talking about the mirror is going to be, this is going to be our mirror. Okay, 45-degree line on this. Is it okay?
Yes.
Okay. So now this is shifted by, this is still y equal to x for, I mean, whatever this value, for example, this is our, I take it as a 3, for example. Okay, our C is a 3. So this is going to be for x plus 3. So take the same point. We take the same point, let's say, but already shifted 3. So now I'm going to write it as a minus 2, 6, for example. Is it okay? Just for example.
Yes, sir.
Diagonally, this is going to be reflecting on the other side, isn't it? Okay, so this midpoint is going to be 0, 3, and this is going to be our same P, Q in this case. Now we can calculate the P plus P minus 2 over 2 is going to be 0, and Q plus 6 over 2 is going to be our 3. Am I right? Okay, P is going to be 2 and Q is going to be 6 minus 6 is going to be 0. That makes sense, right? So the point is going to be, actually my diagram is not that good. It is 3 up and the another 3 up. Do you get that? This has to be 3 and this has to be 3. So that is where it is going to be. So now let's change the slope. What will happen if the slope is changing? Is it okay? So if the slope is changing, let me use the time being, I will use the, but the y, the c value, we know how it works. Now I'm going to use a slope, which is y equal to of x, right?
Yes.
You take a point, the same point. Now this is going to be now this won't seen as a circle. This will become a ellipse. Do you get that? Hello?
Yes, sir.
This will reflect, but now we cannot draw a circle. We have to draw a ellipse. Do you understand that?
Yes.
Okay. So here we have drawn a circle with the R, but now this is going to be, the R is equal, both in this side and this side, it was equal. Right. But this time it is going to be like y value will be only half of the x. That is what the line is saying. Do you get that?
Yes.
So when the y is, yeah, okay. So this point will get reflected. Both of them will change the sign. But what will happen? The x value same, it will remain the same, right? In the negative, I'm saying that it will get reflected. And the x value will remain the same. Right?
Yeah.
X value will become, so for example, if it is a minus 2, 3, for example, then x value will become a 2. This will be a 2, but this will be only half of that.
Okay.
Okay, so that will be 3 minus 3 by 2.
Yes, sir.
Minus 3 by 2. So it will be a 2, minus 3 by 2. And let's say if you have this, okay, and if you have a shift also, let's say if you have a shift of this, so we are going to say that it is going to have a shallow one, that is y equal to of x, then add a 3 to this, then take a point. In a case like, let's say we are going to say that it is going to be minus 2, 6, then it is going to get reflected, right?
Yes.
But this time around, we are saying that the minus, yeah, so the minus 2 will first multiply with the minus 1. That will be, no, it will be still 2, right? X won't change. I'm not getting a clear picture. So can you see it? I'm saying y will be halved and then it will be
lesser than.
So what is the procedure they are saying for the in the textbook or the teacher?
Yeah, sir. It's a similar example question once. I'll send that once.
Because both the M and C are going to play, but M will be scaling and C will be shifting. That's the thing we need to see. Yeah. Because I thought we can come to a good, easy procedure for that, but because it is a rotation by 180 degree from his position, and that distance.
I've sent it to you.
Yeah, okay. It's downloading, right?
Okay.
Because my phone will download quickly, but the desktop WhatsApp takes time.
Okay.
Okay. So this is a problem. First one is a problem. Second one is they are saying that, okay, so they are using a x minus 3y plus y equal to 0, right?
Yes, sir. 3y plus, yes, 3y plus 4 is equal to 0.
Okay, so what they have done first. Therefore, the line 1 is the...
They are telling that PQ, like point P is the point P will be the point that we are taking, and point Q will be the image.
Yeah.
So they are assuming that
first,
is at 90 degrees.
Okay, so they first calculated the slope of PQ. Okay, so they are finding the perpendicular line.
Yeah.
Okay, and then what they are doing? So that they are saying that K is what and H is what? K is
they're telling H comma K is the image.
Okay, I get that. So they are taking, okay, so the original point, okay, so K minus 2 over this one must be equal to minus 1 over, okay, or this is, okay, under the midpoint. Okay, first they find a connection between the H and K, and then they are using the midpoint as the strategy, right?
Yes.
Okay, so that point is going to be on that straight line. Okay. Okay, this is a good idea. Okay, let's do it like with our understanding. Okay. So now, are you seeing the new page in the?
Yes, sir.
Okay. Let's say this is the one we are going to use, y equal to mx plus c. Use the general line. Okay.
Yes.
So this is our okay, I will use it as a y1 equal to m1 c1. I will use it like this. Why I am doing that? Let's say we have a point P and this coordinate point is A comma B, for example. So now when it get reflected, it will be perpendicularly get rotated to the other side, right?
Yes, sir.
Okay, so let's go here. and write this point as a Q. So this is getting reflected. This is a Q, and this Q is going to be our new point. Call it as a PQ is okay. PQ is
Yes.
okay, right? Let's say it is a PQ. So first of all, this itself will be a straight line, right?
Yeah.
So that will follow something like a y2 equal to something like a m2x plus c2.
Yeah.
Isn't it? So first of all, we know that the m2 is going to be our minus 1 over m1, right?
Yes.
So
Yeah.
that straight away tells that this equation is going to be y2 equals minus x over m1 and plus c2.
Yeah.
The understanding. And then we know these values, known quantities are our m1, c1, ab, right? The points, 2 points I'm saying, these 2 points are
Yes.
PP points. Now we need to finally get the PQ in terms of all these known values. So now still the C2 is a unknown quantity, but this whole straight line will pass through AB, right?
Yes.
Pass through AB. So if that passes through the AB, then what we can do? So this will follow B must be equal to minus A over M1 plus C2. Is it okay?
Yes.
So this gives C2 is nothing but B plus A over M1. That also known now. Okay. So the Y2 equation is going to be our simply minus X over M1 plus our B plus A over M1. All of them are known here now, isn't it?
Yes.
Okay. So now look at here. So this the 2 points what we are talking, they all going to, so this point is going to be our midpoint and they all fall on this line. Do you get that?
Yes. Yeah.
Okay. So that means what we could do, P plus A over 2. This point is going to be some point. Yeah, this point we know, right? This is P plus A by 2, comma, Q plus
B
by 2. So this is this point. So now both the P and the Q are unknown. So what we could do, okay, we have, okay, this intercept is also quite good, quite nice. Okay, so what we could do, so we will have equation involving this and this, because this point is passing through both the lines. Do you get that? Pass through this
Yes.
line and also this line. So use that. So in that case, what first use this equation, y1 equal to m1 x plus c1. Then in this case, our equation will look like q plus b over 2 must be equal to m1. Our x is our p plus a over 2 whole thing plus c1, right?
Yes.
And we will have another equation which will look like our, no, this is one equation that we got, right?
Yeah.
And the same, when you use this equation, it will look like our q plus b over 2 must be equal to minus of our p plus a. Okay, I will write the 1 over m1 multiplied by p plus a over 2 plus b times b plus a over m1. Is it okay?
Yes, sir.
So now look at these two equations. So both these two must they have two unknowns, but this side they are having a same value, right?
Yeah, so we can equate.
Yeah, we can equate this and we can solve for the P.
Yes.
And once
Yes,
we
sir.
solve for that P, then we can
Okay.
solve for the Q. Does it make sense for you?
Yes, yes, sir.
Okay, so I mean, I went in a different way to do that, but you see, I mean, even when I see the textbook, still I want to feel comfortable with what we are thinking. We have to go to the level where we have an understanding and start developing on that.
Yes, sir.
Right. So the clue from the textbook was this particular point. This did not click me very quickly. Okay, so we could find the straight line for the both the intersecting perpendicular orthogonal ones, and then we can build upon that. Is it okay?
Yes, sir.
So you feel confident now, right?
Yes, yes, sir. Yes.
So you want to solve that particular problem, the one in the book. The problem is, for example, the one you sent earlier. What is that?
Yes. 3, 8 is the point.
Yeah. Well, okay. Let me take it. Okay. So the A is 3.
Yeah.
B is
B is 8.
8. And the equation is
X plus 3y is equal to 7. Or x plus 3y minus 7.
X plus 3y equal to minus 7.
No, x plus 3y is equal to 7.
Equal to 7. So now we can write this as y is actually minus 1 over 3 plus 7 over x times 7 over 3, right?
Yes.
Plus 7 over 3. So with this, A, B, directly the numbers are available. So the M1 is minus 1 over 3 and our C1 is 7 over 3.
Yes.
Isn't it? So with that, we can calculate our C2 is nothing but, okay, first calculate the M1. M2 is actually equal to 3.
Minus 1, 3.
Yeah, that will be 3. And then C2 will be 8 plus 3 over our M1. That is going to be minus 1 over 3. Am I right?
Yes.
So this is going to be 8 minus 9, right?
Yeah, 8 minus.
Yeah, that will be minus 1.
8.
So we got that. This equation, so we got these two values. So we got the, let me write it in the box here. So the one we got was M2 is actually equal to 3 and C2 is actually equal to minus 1. Am I right?
Yes.
So now let's write this one. This one will be M1 is minus 1 over 3 whole thing. P, A is 3. P plus 3 over 2, close the bracket, and plus C1 plus 7 over 3, right?
Yes.
This must be equated to, this side will be minus 1 over M1, that is our M2, that is our 3 itself. 3 multiplied by P plus 3 over 2 whole thing. This is our C2, right?
Yes.
Is minus 1. This is good. So now bring that. So let me take a bit of a room here. So here I write somewhere. Negative. I bring the. So that will be 3 plus 1 over 3, right?
Yes.
3 plus 1 over 3 whole thing multiplied by P plus 3 over 2 is actually equal to 1 plus 7 over 3. Right?
Yes.
Yeah. Okay. So now take the LCM. So this will be 11 over 3. Am I right? No, 10 over 3.
10.
No, 10. 10 over 3 times P plus 3 over 2 is actually equal to, here 3 plus 7 is, this also 10 over 3?
10.
No. This is also 10 over 3?
Yes, sir. Because
So they give it, yeah, 9 plus 1. Yeah, that is right. So this gives P plus 3 over 2 is actually equal to 1. then P is actually equal to 2 minus 3, that will be minus 1. Check the answer.
Yes.
The answer is minus 1. The X value. The reflected.
1 second.
Yeah. Hmm?
1 minute after. I'm just
Yeah.
Number. Yes, uncle. It's minus 1. X value is minus 1.
Yeah. So now use the calculate the Y value. The Q is nothing but our M. We can use the second equation. M2 is easy. That is 3 times minus 1 minus 1. So the Q value minus 3 minus 1, it will be minus 4.
Minus 4. Yes. That's yeah.
Okay, so the
minus 1.
minus 1 comma minus 4.
Yes.
You're okay.
Yes, uncle.
Okay, we went a bit away, but now you got the good idea how the reflection
Yes,
be done. Is it okay?
Yes, sir.
Okay then. Okay, see you next week.
Yes.
Okay.
Yes.
Okay.
Thank you.
Yeah, bye.